All right, so now what we're going to do is, now that we know that we can measure angles in radians, but we've already known for a long time that we can measure angles in degrees. So since we know that both of them can be measured in angles and degrees, then there must be some way to convert a degree measure into radians and to convert a radians measure into degrees. Now this is the very same thing as converting between inches and centimeters, or the same thing as converting from Celsius into Fahrenheit, or the other way around, okay? The idea here is that we're just converting objectively between two units of measure that measure the exact same thing. Now, before I give you the formulas, and there are very simple it's a very simple formula for both of them, and it's basically the same formula, just backwards. I want to walk you through why the formula works. We know two things about circles and degrees. We know that halfway around the circle, half of a circle, all right, so half circle, we know that half of a circle is 180 degrees, right? From here all the way around to halfway, that is 180 degrees. And we know that a whole circle is 360 degrees, right? So half a circle is 180 degrees, a whole circle is 360 degrees. We also know, based on what we just learned, that in radians, if the radius equals 1, only in the situation where the radius of the circle is 1, that's where we can get the radian angle measure, is only if the radius of the circle is 1. That when the radius of the circle is 1, the radian angle measure of half of a circle is pi. Now I can prove this to you. Let's say that we had 8 slices. 1, 2, 3, 4, 5, 6, 7, 8, right? And half of the circle would be 4 out of 8, right? So 4 slices out of 8 slices. And we know that if the radius is 1, that the circumference would be 2 pi. So circumference is 2 pi, 4/8. If we did 4/8 times 2 pi, we would get 4 times 2 pi is 8 pi over 8. The 8's cancel, and all we have left is pi. So the radian angle measure for half of a circle that has a radius of 1, the radian angle measure is pi. And we already know that the radian angle measure, the circumference of a whole circle, when the radius is 1, is 2 pi, because circumference is 2 pi times radius. Radius is 1, 2 pi times 1 is 2 pi. So for a whole circle, we know that the radius is, or the angle measure for the entire circle is 2 pi. So that means that if we were to use the idea of a half circle, we know that 180 degrees is equal to pi radians, right? Or we could say that 360 degrees is equal to 2 pi radians. Sometimes we say rads, okay? And we can now use this equation or this equality, this conversion, to either go from radians to degrees or from degrees into radians. And here's how we're going to do it. Let's say, well, let's go ahead. Here's what we're going to do. If both of these things are equal to each other, right? If 180 degrees is equal to pi radians, then couldn't we then say that pi radians divided by 180 degrees is equal to 1? Isn't that true? Because if these two are equal, we know that anytime you take something and divide it by what it's equal to, your answer is 1. Now, technically, it would be 1 radians over degrees, okay? But here's what I'm telling you. I want you to relax this, unless you are a die-hard math fan, okay? And if you are, then I recommend that you investigate further why the units matter. And they do matter. But really, this is what matters to me, is that you understand this idea of pi over 180. Of course, we could just as easily, actually I should have put this one over here. We could just as easily say that 180 degrees divided by pi radians is equal to 1 also, in which case our fraction is simply 180 over pi. And these are our two conversion factors. Basically what we're doing is to convert from degrees into radians, we're going to multiply by one of these two things. And to go from radians into degrees, we're going to multiply by one of these two things. And I'm going to show you how to know which one. Okay? So for example, let's say a 90-degree angle. We want to turn 90 degrees into radians. In order to turn degrees into radians, you're going to want to start writing this down. This is now the how-to. Okay? We want to put, what we want to end up with basically is a fraction that has a pi in the numerator, because all of our radian measures have a pi in the numerator. Okay? So in order to get a pi into the numerator, we need to use the one that already has a pi in the numerator. So what we're going to do is we are going to multiply 90 degrees by pi in the numerator over 180. And if we did 90 degrees times pi over 180, see, here's where the units come in. Technically, this is 180 degrees. And so what's going to happen here is the degrees are going to cancel each other out. And all you're going to have is 90 times pi is 90 pi over 180. And then the radians is sitting next to the pi. We have rads here, which means that the answer to this is in radians or rads. Okay? So but that was just a little aside. But let's ignore that. You really don't need, I'm not going to crucify you on the units. I just care about the fact that you go from 90 degrees. Now you do need to put the little degree symbol on the number, but to go from 90 degrees into radians, we need a pi in the numerator, which means we need to use pi over 180. 90 times pi is 90 pi. Carry over the 180. And now watch this. Now we just need to reduce 90 over 18. Now, I know that 90 can be divided by 10, and 180 can also be divided by 10. If I divide both of them by 10, I get 9 pi over 18. But now I look at it again and I say, hey, wait a minute. I also know that 9 is divisible by 9 and 18 is also divisible by 9. So I can reduce it even further. So this is actually going to become 9 divided by 9 is 1. So that means I'm just going to put pi. I'm not writing 1 pi, just pi. 18 divided by 9 is 2, and therefore my final answer is pi over 2 radians. So a 90-degree angle is the same thing as a pi over 2 radians angle. That is how we convert from degrees into radians. Okay? I want to give you another example, or maybe 2 or 3 more examples. All right, why don't you try these 3? Let's convert 40 degrees, 50 degrees, and 285 degrees into radian measures. Okay, let's see how you did. I hope you paused the video and you tried it. So because we want to put a radian into it, because it doesn't have, or a pi into it, because it doesn't have pi yet, all radians have to have a pi in them. Well, generally speaking, have to have a pi in them. So we're going to multiply by pi over 180, right? So 40 times pi is 40 pi over 180. We can cancel the 0 because both of them can be divided by 10, which gives us 4 pi over 18. And 4 and 18 can both be divided by 2. And so when we divide 4 by 2, we get 2 and then the pi. And then 8 divided by 2 is 9. And therefore, a 40-degree angle is the same thing as a 2 pi over 9 angle. Okay? All right, 50 degrees. Again, we're going to multiply by pi over 180. 50 times pi is 50 pi over 180. We'll cancel the zeros again. And we get 5 pi over 18, which cannot be reduced. Therefore, this is our answer, 5 pi over 18. Last one, 285-degree angle times pi over 180 gives us 285 pi over 180. Now we can't divide by 10 in both of these, but we can divide by 5 in both of them. So if we divide 285 by 5, I'm going to grab a calculator, or this one. All right, so 285 divided by 5 is 57 pi. 180 divided by 5 is 36. Okay, and actually, this is interesting. 57 and 36 are both divisible by 3. Okay, so 57 divided by 3 is 19. So 19 pi. 36 divided by 3 is 12, and therefore our final answer is 19 pi over 12. So a 285 degree angle is a 19 pi over 12 radians angle. Okay? All right, so that is converting between degrees and radians. Now let's try converting from radians to degrees. Okay, now to convert between radians and degrees, let's go ahead and, let's start with something like 5 pi. In fact, let's do one we have over here. Let's take this 5 pi over 18 and see if it really turns into 50 degrees. 5 pi over 18. Now, when you have a radian angle measure, it has a pi in it, a pi in the numerator. We want to get rid of the pi in the numerator. And the way that we cancel out the pi that is in the numerator is we need to put a pi into the denominator. If there was a pi down here in the denominator, we could then cancel it out, right? Okay, well, how can we get a pi into the denominator? We can get a pi into the denominator by multiplying by a fraction that has a pi in the denominator, and that fraction is 180 over pi. So our conversion factor that we're going to multiply by to convert between radians and degrees is 180 over pi. It's the reciprocal of our degrees to radians conversion factor. So over here, we're going to multiply by 180 over pi. Okay? And now you can do it this way if you want to, or you can multiply it all out and then cancel. But I can see right away that this pi and this pi are going to cancel. And so now both of the pi's are now gone. Let me grab my calculator. It's around here somewhere. There it is. And now I got to multiply 5 times 180 is going to be 900 over 18. Okay? And so now I know that I can divide 900 by 9 and I can divide 18 by 9. 900 divided by 9 is 100. 18 divided by 9 is 2, and now I have 100 over 2 degrees, and 100 divided by 2 is 50. And therefore, a 5 pi over 18 radians angle is the same thing as a 50 degree angle, which is exactly what we had over here. Okay? Now I'm going to get a few more for you to try. Okay, so let's try these three using our conversion factor, 180 over pi. Why don't you pause the video and try them? Okay, so let's try 7 pi over 4. We know we're going to multiply it by 180 over pi. We know that the pi's are going to cancel. 7 times 180, I'll grab a calculator here. 7 times 180 is 1,260 over 4. I'm pretty sure that divides out. We're going to divide this by 4 and we get 315. So this is the same thing as a 315 degree. You have to put the degree symbol on there. 315 degree angle. Okay? A 7 pi over 4 angle is a 315 degree angle. Okay? Let's try 2 pi over 11. We're going to multiply by 180 over pi. Okay, so the pi's are going to cancel. 2 times 180 is 360 over 11. Now this one I'm going to do it in the calculator, 360 divided by 11. And it's actually going to give me a decimal answer. Now if you want to write it as 360 over 11 degrees, that's fine. But for degrees, it is far more appropriate to use decimals. With radians, it's more appropriate to use a fraction with a pi in the numerator. With degrees, it's more appropriate to use a decimal. So I'm going to write this out as 32.7273. That's rounding to the fourth. 7273 degrees. Okay? Actually, you know what? Let's just go to the second decimal place. Let's just do 32.73 degrees. Okay? Go to 2 decimal places. Right? All right, let's try this one. Pi over 17 times 180 over pi. Cancel the pi's. And now what we have is 180 over 17. Put that in the calculator. 180 divided by 17 gives us 10.59 degrees. 10.59 degrees. And so a pi over 17 radians angle is the same thing as a 10.59 degree angle. And that is how we convert between from radians into degrees and degrees into radians. This is your introduction to radian angle measures in trigonometry. This is the very beginning. We're going to do a lot of stuff over the next several weeks, or next few weeks anyways, in trigonometry, in understanding these angle measures, understanding this circle, and understanding triangles as well, which you probably recall from geometry, okay? All right, well, that's it for now, and we'll see you in the next lesson.